Hello friends, welcome back to the bench. Our patient is this beautiful 90s Nickelodeon alarm clock. This is the second one we got. The first one had an issue with the display. This one has very unusual issue. Well, it's hard to say, hard to call it unusual since I already done two of them. But unusuality of this case is because the clock came here because of no volume, right? So my first thought was the potentiometer went bad, because they do after a while, and stopped conducting. And depending on the circuit, it might completely remove the volume. In other cases, it might be just very quiet, very low power coming from the speaker. So this is not the case. This is not the case we have here, because the volume works. But what I assume is going on here, or why the clock is here, is that it doesn't work as an alarm clock. So it is now, well, it's showing 12:14. So if I set the alarm to 12:15, right, in a minute, and I turn it off, as it goes to 12:15, you can't see that on the camera, the display. This is only to be read by humans. It's 50 there. It went to 15. Alarm went off, and I don't know if you'll be able to see that, but we have a little blinking. See that blinking? So it's trying to do something, right? Probably depending on this knob over here, we're selecting whether to play radio or whatever. So it's trying to do something. There's no audio clues coming from it, like clicking or anything like that. So this is probably what this piece is here for. Now we have the full volume. So if I click this, I turned off the alarm. It stopped blinking, right? So the alarm is turned off. Now if I click it again, it turns the radio on. So this is what should have happened when we went to 12:15 or 16, whatever, when the alarm is supposed to turn on. But instead, it's turning on and off with this knob. That's not the expected behavior. That's not how it should work. Now, if you switch alarm off, oh, it still turns on the radio. Yeah, I guess when you're on demo, it does nothing. It also should do something. So it's not a volume issue. The blinking kind of points me to, just like we had an issue with the display, not enough power was going to one of the rails, so it didn't light up. And in that case, that was a faulty diode. In this case, it could be the same. It could be the same thing. It's just different diode somewhere else. Not enough power is going to the circuitry responsible for turning on the alarm. In addition, again, you probably won't be able to see that, but when you press this button, this should light up. And it is lit up a little, but it doesn't turn on when I click it. It should turn on. Oh, now it did. Okay, so, oh, and now it turned on. I don't know if you can see that. Now it turned off. Maybe it's better when, yeah, but you can clearly see it blinking. Should it be blinking? Maybe it should, because it's, you know, it's an alarm, but I'm not sure. It doesn't seem to be blinking the way I would expect it to blink. Okay, so here's my theory. It could be, because I'd never owned one of these, and the last one I had, I didn't check that. So this is what might be happening. When the alarm clock is going off, it doesn't turn on the radio, it turns on the buzzer. So that blinking is sending the beeps to the buzzer. And as you turn off the alarm, the second click will turn on the radio, or the first, because the first one just turns off the alarm, right? And then you can click again to turn on the radio. So either the buzzer is, if I'm right about this, because I don't know, but if I'm right about this, then probably the buzzer stopped working, and or the buzzer driver. So let's open it up and see what we can see inside. Well, there is no buzzer. These cups looks like leakage, but not necessarily. This can be, yeah, this might not be a leakage. You know, busted cups would perhaps explain this behavior, because again, that blinking, that could suggest that there's, I know, the circuit's not turning on because voltage drops. So that's the driver for the LCD, if I remember correctly, and that's the radio. Or, well, that's not really a driver for LCD, that's a built-in clock. The clock built in to the to one chip. So it has everything. As if I saw a buzzer, then we could test the buzzer, give it some power, and see if it works. But that doesn't seem to be the case. Let's shall we see the other side? But the other side should be clean. I think that this is just a single side board, as it used to be back in the day. Maybe nothing, maybe something. It's from afar it looked like blown transistor, which would also explain the behavior. Small transistors like this, they typically don't blow this way. Power transistors do, but usually not the little guys like this. But if it has been over voltaged, then yeah, that's possible. Well, there's no shorts on it, and it looks good. It was just that coating on it that looked weird. I was thinking that maybe it was the transistors getting hot, and that's what caused that mark. Okay, so that didn't take too long. We've got the pin out. Now we have pin 16, which is alarm out, and I just tested it. Let me see if I can reproduce it. Basically on this pen right now we have roughly 250 millivolts, and when the alarm goes off we have 12 volts here, and we have 11.4, 11.7. It's fluctuating a bit, but it is high. It goes to 12 volts, so our output is fine, or our chip is fine. Now that power from that chip is now going somewhere, and according to this schematic over here, so I'm not too sure what to make of this. So our alarm out, and this is probably a capacitor going to ground, resistor, and DC out. That's what the schematic tells us, but this is not exactly the schematic for this particular device. It's just the typical application of this chip. Okay, I think there's no way around it. We need to dig the board and see on the other side, which is a pain because some of these screws need to be removed, but not all of them, and I don't remember which ones they were. And in addition, once you remove the board, all these clickers on this side are gonna fall out, and some of them are held by those screws and some of them only hold the board. But maybe before we do that, let's see if we can get lucky with the multimeter and just find, just like we do for ECMs and stuff. All right, we might get lucky. Okay, we got lucky. So this resistor, 1K, this 1K resistor goes through this wire, if I'm reading this correctly. Is this 1K? Let's see. Black and red and brown, black, orange. So it goes here. Through this resistor. Let's see, this resistor is 20K almost. So this might be a ballast. I don't think that's, yeah, the 1K I understand, but 20K, that's probably not what we're looking for. We're kind of going here to the transistor, yes. So probably here, nope. Not here. Oh, the middle pin. The middle pin is usually the collector. Okay, so what we need to do, even now, without getting the board out, let's just follow the voltage, right? And let's see where it goes, where it disappears. And that might give us something. Okay, so it looks like here's the issue. So this transistor, indeed, we get 5 volts here. It goes through the output of from the output of the chip to this resistor. It goes through quite a few resistors. Now it's fluctuating because probably we're getting what do you call it? A wave over here, right? We're getting signal. Actually, let's see that signal. Well, it doesn't seem to be a signal, so that is curious, because I was expecting that this transistor over here is going to be just an amplifier, and the little wave coming from the chip is going to be amplified through it to the speaker. That's actually a common use for this transistor. And this transistor is NPN, and we get 5 volts over here to the base. As you can see, it drops to 0.6, and here, this is the collector. Collector voltage dropped to 32 millivolts, hence the emitter is at 0. Now, this could be 2 problems here. Problem number 1, the maximum available current on the collector is too low. Problem number 2, or possibility number 2, the emitter is shorted. So first let's eliminate a short on the emitter. Yeah, we got short on the emitter. So that's the problem. Okay, I'm glad I didn't go down the path to check the collector. So when the clock is in it's not ringing, right? The alarm is off. We get nice, I don't remember, 2.5 volts or something like that here, right? We don't need much more. We push 5 volts to the base, so the transistor opens and it shorts out. So this, that's not necessarily a problem, because this transistor, the emitter of this transistor, could sit on the ground, and it is just controlling the collector. That's typically more of an digital circuit. You would expect that in the digital circuit, not with this transistor. But nothing prevents you from using this transistor as in a digital circuit. So basically, that 2.5 volts, we want to drop it to, nearly 0, 32 millivolts. So that could be normal. We could inject voltage over here, but without confirming that it's not supposed to go to ground. It's a dead short too, right? Let's check that again. Yeah, it's dead short, so it could be that it's supposed to go to ground. It's even close to the ground pin over here. I don't know. So this might not be the issue. The issue might be somewhere else. But there is no signal. So we're not getting a wave that would be amplified by this transistor and sent to the speaker. It looks like it's just pumping 5 volts just to open this transistor. Okay, so I went through the documentation again, and just to confirm what should be the output of this pen, because we get 12 volts, pretty much steady 12 volts. Now the output should not be 12 volts, and the output should be on 900 hertz or 900 hertz signal with 50% duty cycle. And as far as the shape of the signal, it can be adjusted. So it can be square, it can be triangle, sawtooth, sinus, I guess. So we're not getting a proper output from this. So this transistor, it probably is sitting on the ground. The emitter is probably sitting on the ground because the short is dead short. If there was, semiconductor shorted, that wouldn't have been 0. There are no ceramic caps on these devices, like SMD caps that usually short out to dead short. So that's probably not it. This is probably all good, and everything on the output over here is good, because it's not supposed to. That's why I can hear some crackling from the speaker, because instead of through the speaker right now, there should be a little bit of current flowing, but in the cycles, right? But instead, we're getting steady 5 volts, which just sends the current through the speaker, and that's why those periodic cracklings from the speaker. And so our control chip is most likely faulty. The output is not correct from it. So what are the possibilities now? What can we do? This is tricky, because you can acquire this clock in a perfectly working condition on eBay for anywhere from like $120 to even over $300, but obviously those probably are not going to sell. The value of the clock is roughly maybe $150, something like that. Now, to replace this chip, which first of all, we don't know if this is the only fault, because something could have caused that to short out. It's probably shorted on the inside. Maybe, I don't know, maybe some external components, but I don't see anything that would. And based on the documentation of the chip, it doesn't require any external components to work. All right, you just connect the power pretty much and few buttons and speaker, and this is it. And obviously the display, right? It's all in one chip, and it's not performing. I confirmed the supply voltage on it. It's fine. I checked with a thermal camera, because if there was a short, we would probably see something heating up. Nothing's heating up abnormally, so I don't see anything wrong with the passive side of the circuit, meaning discrete components around it. So I conclude that it's the chip that needs to be replaced. Now, can you find that chip? Can you get that chip? It's kind of hard. It's kind of hard because there are replacements that were produced some time ago, but obviously this hasn't been produced in a long time. So once you buy that chip, you don't really know if it's gonna work, even though you bought it new, because it happens that the chips are basically fake chips are being sold. It happens. So there's a risk number 1. Risk number 2, replacing that chip means we have to disassemble all that. As you can see how it's built, right, with wires and everything. Once you start poking around here, it's very easy to break something, right? And then to find something that broke is even worse. So my conclusion is that the price I would have to give you for the repair of this one will greatly exceed the value of this. So I don't know, it's your call, but it's gonna be probably twice the value of this device to get it repaired, and it's gonna take a while. So I'm just gonna leave it to you if you wanna get this particular piece fixed. If not, well, if I found one on eBay for like $69 or something like that, with broken, the case is broken and this is missing. So there's a good chance that, or there's a chance, not good chance, there's a chance that electronically it is fine, that the board is okay, and we can just transplant the board from that one to this one. Again, it's still pretty costly. that's the best I can do. I was expecting, you know, a faulty potentiometer or something like that, but this is a lot more intricate. So I don't know. Anyways, I'm gonna send this video to the customer, and we'll see what the customer wants to do with this. Sorry, no repair today. No successful repair today, but at least we know what's wrong with it, right? So that's actually the most difficult part of this job, is to figuring out what's wrong, because then fixing it is not a big issue. It's finding what's wrong that is hard. Well, anyways, if you guys liked it, leave a like and leave a dislike if you didn't, and I shall see you guys in the next one.